Hi, this is Mark Kemper with EMS, and in this video we're going to demonstrate the new Surphaser 100 HSX long-range 3D scanner. Now, Surphaser's long been known in the industry as offering the highest accuracy, highest resolution, best data quality available in a long-range scanner. If you talk to anybody in this industry, they can tell you that the Surphaser has no equals when it comes to accuracy and data quality. Typical applications for this scanner are things such as aircraft, military vehicles, automobiles, boats, large industrial equipment such as power generation, big impellers, big housings, big castings, things like that where you need very good data quality and accuracy either for inspection or reverse engineering. Okay? Now, what we're going to do in today's demo is we're going to talk about the new 100 HSX and some of the new features of this model over its predecessor. We're going to talk about how it works, how the scanning actually works, and then we're going to talk about downstream applications, how we take the raw scan data, how we put it together, merge it, align it, and then what do we do with it as far as for inspection, reverse engineering, and we'll also look at some sample projects, sample objects we've scanned with this scanner. Okay? So let's first start and talk about how this scanner works. Okay? This is what's called a phase-based scanner. Okay? It's laser-based, phase-based. It's a class 3 laser, so it'll work in direct sunlight, outdoors, indoors, doesn't matter. What you have here is a mirror on a 45-degree angle that spins around, as well as the whole base itself spins around. So it's able to scan 360 in both directions, captures data 360 by 270, because obviously we have the base of the scanner here. It can't scan underneath itself. So you just end up with a small hole right underneath the scanner where there's no data. Okay? But the way phase-based scanning works is there's a laser in here and a sensor. Laser shot out, hits the mirror, redirects out until it strikes something, changes phase. The sensor picks that up, and basically it's recording depth. So one point at a time, it's collecting an XYZ value of where that point is in 3D space. Okay? But because it's moving 360 by 270, or really 360 by 360, but capturing 270, it's collecting up to 1 million points a second. So it's literally a laser line that gets, sent out and strikes an object and gets returned and recorded to the scanner. Okay? So that's essentially what phase-based scanning is, laser-based type scanning. Now, let's talk about the new features of the 100 HSX. First thing is it's smaller size than its predecessor. It has a handle now on top for carrying it around or moving it or mounting it on your tripod. It has battery operation, and it has remote control operation. So the battery operation is great because when you're in a remote area and you don't have power that's easily accessible, in the past we'd have to take a generator. With this new one, we can take multiple batteries and run all day long in a remote application. The other thing is it's remote control. So what that means is I can either use my smartphone, a tablet, or a PC and wirelessly or remotely talk to the scanner and tell it what to do. Okay? And we're going to get into that and show that here in our demo today. So we can remotely control it, and it's battery operated. Because many times we put it on a jib arm, we might put it on a scissor lift and go up high, mount it up on some scaffolding or some railing. So not having to drag power, not having to have our PC right next to it with a data cable is a big plus in this new unit. So again, even better accuracy, even better data quality, smaller size, battery operation, and remote control are all the new features of the 100 HSX. Okay? So what we're going to do here first is start, and we're going to scan. We're just going to use this trailer for our demo today, and we're going to show you how the actual scanner works, take some sample scans, and then we'll talk about the downstream applications, go into more on the software side of things. So let's get started. And the first thing we're typically going to do is what we call a preview. Okay? The reason we want to do a preview is because most of the time we don't do a 360 by 270 scan. Now, if I were doing this room and I wanted everything, I would do it. I would put it in the middle and just tell it to scan. But most of the time we're scanning an object in an area. Okay? So what a preview is going to do is it's going to take a very quick scan at kind of a low res, allow us to window in the areas or area we want to scan, and then it'll go back and scan it at a higher res, which we're going to control. Okay? So again, it's just doing a quick scan, and then we'll go back and tell it where to scan and by what resolution. And how resolution is controlled with this is lines per degree. So what that means is if you took 1 degree and you sliced it up, that's your lines per degree. And this scanner will work anywhere from 24 to 92 lines per degree. So what really dictates that is how far away your object is and what kind of point spacing or density you want. So for example, if our trailer is 10 feet away and we want 1/8 inch spacing, the minimum of 24 lines per degree is probably fine. If our object was 50 feet away and we wanted an 1/8 inch point spacing, we might need 50 or 60 lines per degree. Now the scanner comes with a chart to aid you in how far, the distance away and the density of points you want, and you just put in that number, okay? But obviously for the preview, we don't need that. We can just do a very quick scan, which it's done, and it's finishing and it's going back home, and then we'll go in and window in the area and tell it where to scan. But we can completely control the density of the data with that lines per degree, okay? So it's done scanning. And what we're going to get here in a second is basically the preview, okay? So here's the entire room. You can see the ceiling, the floor, everything except right underneath the scanner. And we simply just come in and we pick 2 points. And that's going to window in the area we want to scan, okay? And I could have multiple areas. I could pick another box up here, another one over here. Sometimes there's objects that, multiple objects we want to scan. And now we just come in and tell it to scan the selected area. So let's talk about the scanning itself. So this type of scanner, as with most, are line-of-sight scanners, meaning if it can see it, it can scan it. So for example, for us to do this entire trailer, we're going to need multiple scans. And we can either move the trailer or we can move the scanner around, okay? Now if you're doing something large, like an aircraft, you're not going to move the aircraft, you're going to move the scanner. And for example, if we want to get the roof, we're going to need to get the scanner up high so it can see down. That could be done with a jib arm. Could be done with this tripod will go up about 10 feet. You could go up on like a scissor lift. Anything to get up and then shoot down and scan. If we want to get underneath and get the frame of the trailer, we could literally set the scanner down on the floor and scan. So, it's not uncommon that we'll have 6, 10, 20, 30, maybe 50 scans, depending on how large our object is and how complicated it is, the different areas we need to scan, okay? So it can be, it can be numerous, and typically is numerous scans. Aligning the data, because we're taking these scans from different locations, we'll go into a little more on the software end, but it's basically either 2D targets or 3D targets, such as spheres. 2D targets are basically a flat target that you can place on the object, or you can just use the object itself to align the data. And again, we'll show some of these different examples later. Okay? But basically now you can see scanning at a slower rate, and it's scanning our object, and when it gets done, it'll return home. Now, this scanner comes in 2 configurations, a short range and an intermediate range. The short range is good to about 30 feet. You'll get data. And the long range is good to about 100 feet. So depending on your application, you'll get, if you're doing basically like vehicles or smaller objects, the short range is a good fit, because it has a smaller laser size, spot size, to get even better resolution and detail. And the intermediate's a little bit larger, that gives you, more distance. So you can get out to about 100 feet versus about 30 feet. So this is the medium range or intermediate range configuration of the scanner. Okay, so the scan is done. We now can move the scanner, do another preview, window in our area, and take our next scan. All the scans are written to an SD card. I could pop this card out, put the next one in if I want to start looking at the data on my laptop. But again, completely remote controlled from the laptop, battery powered, written onto an SD card. And again, the reason it's on an SD card and not done wirelessly is these scan files typically are 500 megs to 2 gigs, and that's just difficult to move that much data quickly over a network. So it writes to an SD card. Okay, so just to kind of go back through and talk about the scanner, what we've showed so far is, again, this is the new 100 HSX. It offers even smaller size than before. It offers the battery operation. It offers the remote control. It offers even better accuracy and better data quality. So it's a great new package from Surphaser, and really the next generation. So the best scanner, the best long-range scanner in the world, has gotten even better. So next what we'll do is we'll go into the software and we'll take a look at all the scans we did on this trailer and show how we can align them, merge them, work with them, how it can be used for reverse engineering, for inspection, and then we'll show some other objects we scan just so you can see the quality of the Surphaser scanner and what it's able to do.
Okay, so here we are with the finished scans of the trailer. Now what we did is we took 6 scans around the trailer and we've aligned those scans. And there's a couple ways you can align the data. We're not going to go into that a lot in this demo, but again, it can be using spheres, targets, or just the geometry itself. And we're in Geomagic Design X, formerly known as RapidForm, which is 3D scanning and inspection software. So let's do this. Let's hide all the scans except one of them and take a look at that first. So here's a single scan of the trailer, and again, you can look at the data quality here from the Surphaser. And again, all this is points, but you can notice here, you can see the rivets, you can see the detail. This is the tread plating here on the front of the trailer, etc. And if I just zoom in on this, you'll literally kind of see it's just lines of points, and this is the lines per degree we talked about in regards to it. You know, and so as you get closer, you can actually see what it is. Again, it's just points, and as you zoom out, you get a better idea of what that data quality looks like. Okay, so let's do this. Let's go ahead and show all of the scans that we did. So we took 6 scans total to walk around. We primarily got the sides. We didn't get the top, but as we discussed, we could put the scanner up high to get the roof area, and then of course down low to get underneath it. Okay, but you get an idea. So it scanned pretty much everything. The license plate area didn't scan because that's very reflective. But you know, the bumpers were shiny metal. It picked them up. It picked up the tires, which are dark. It picked up the rims. So pretty much everything else scanned. Now all we have here again is a series of 6 overlapping scans. And you know, if you look at each one of these point clouds, they're anywhere from 280 to 533,000. It'll just vary a little bit, 360,000. So you can see you can quickly end up with millions and millions of points depending on what you're scanning. Okay, but essentially what we've done here is we've aligned these 6 scans through various methods and brought it in here. Now at this point, Design X will allow you to work with these raw point clouds. You can cut sections. We could take measurements. So for example, if I just wanted to measure from here to here and find out what that distance is, or here to here, we could simply do that. So you can do and work right with this raw scan data depending on what your application is. The other thing we can do is cut sections and build solid model data, or we could do inspection. We could load in a nominal CAD file and inspect this part. The next thing we want to do is actually merge all these scans together and turn it into a polygon model. We want to take all these overlapping scans, merge all those points, and turn it into polygons. This could be helpful if we were going to do animation, maybe CNC machining, 3D printing, you know, others, various downstream applications, or reverse engineering. There are some benefits of turning it into polygon data. So we simply tell it to merge. We'll select all of our point clouds, and we'll go ahead and hit execute this command. Okay, for time purposes, we paused the video because it actually took a couple minutes to merge the scan data and turn it into polygon data. But once it's polygon data, it's basically triangles, okay, instead of points. So as I zoom in, you're not going to see little points. You're actually going to see triangles. And if I turn down the triangle edges and continue to zoom in, basically you'd see everything as triangles instead of points. And there's some advantages to turning this into triangles, as I mentioned, for reverse engineering and different things. But now we've got polygons. But again, you can see the incredible accuracy. You notice how you can see all the rivets. Every dent in this trailer is picked up. And again, this data has not been cleaned up. It hasn't been smooth. It hasn't been massaged in any way. You're looking at the basically raw point cloud converted to polygon data. Okay, So again, even a black tire, you're going to get some noise on the black tire, but this is shiny metal. This is tread plate on the front. You can even kind of see the chains here and so forth. So just incredible data. And again, we were at the lowest resolution setting of 24 lines per degree. So again, you can see what that looks like. And then now we're ready for reverse engineering, inspection, really whatever we want to do, which would be our typical reverse engineering or inspection process, which we have other videos that go into that process and show in more detail. But this is just a quick overview of the Surphaser. So what I'd like to do next is just load up a few other files, and we'll kind of talk about some of the other things we've scanned with the Surphaser, just to give you an idea of what the data quality would look like on some other objects. Okay, so what you see here is the scan data from a very large aircraft, as you see here. And again, for time purposes, I've already loaded this up. But you know, this was effectively, I believe, about 60 scans to get the entire aircraft. So you can see we've got the complete underside of it, the top of it, pretty much everywhere. Obviously, where there's windows and stuff, it didn't scan. The propeller bays were a real dark black, and had a little trouble picking those up. But you know, for the most part, you can see all the data. And then what we did from there was built a complete feature-based solid model of this entire aircraft, including the landing gears and a lot of the details on here, the windows, the doors, the antennas, and so forth. So we can build a very detailed CAD model from that scan data. And again, because the Surphaser has such high accuracy and resolution, we can build a very high quality, high accurate model from that scan data. Okay. So let's so here's something very large as an aircraft. Let's show something else. I'm going to load in next, maybe an industrial pump or impeller. Okay, so here we have a large industrial impeller, and if we were to measure this, this thing is about 4 foot in diameter, just to kind of give you an idea of how large it is. But again, you can see the data quality of the Surphaser. I mean, it's going to pick up just an incredible amount of detail on this part. So any nicks or dents or anything on this impeller, it's going to pick it up. You can see some of the surface texture here. And again, all this is raw scan data that's been merged together into a polygon file. You can see some pitting on the edge of the impeller here. So again, for some of this really high detailed, high quality work, the Surphaser is second to none. I'll turn on the CAD model we then created from that scan data, which you see here. So this is a feature-based solid model done in DesignX from that raw scan data. Not only can we create that CAD data, but then we can also run analysis on it and basically inspect our new CAD model back to our scan data and see what it looks like. So we've designed the perfect CAD model, which may or may not match the scan file because we made everything symmetrical. But you can basically see color-coded differences between the scan data and the CAD data. So let's go on and load. I'll load up some sculpture that we recently scanned with the Surphaser next. Okay, so what I've loaded here is a statue we scanned. This statue was basically full size. So with the rockwork at the bottom, it's actually about 7 foot tall, and we've got 2 soldiers here. This was scanned so that it could be scaled up to about 9 or 10 foot to make actual bronze statues. So again, if you zoom in and look at the incredible detail that the Surphaser was able to pick up. Okay, so you can see here on their backs. Let's roll it around to the front. Okay, and this was quite a few scans, both the high and low, to get all the areas on these soldiers. But again, you can see what the Surphaser is capable of doing. And this is actually about 18 million triangles on this scan that you see here. Okay, and the last one I'm going to show here, this is a Chevy Tahoe. This was just a handful of scans, about 4 or 5 scans around the vehicle. Obviously we didn't get up on the roof and underneath it. And this was a production vehicle, and again, just to show the data quality. And this vehicle wasn't dusted or treated in any way. You're looking at really, again, the raw scan data on the vehicle. Okay, so again, certain things like that are really shiny won't pick up. For example, these chrome handles. Obviously, things that are very translucent like glass, you're really not going to see anything. But again, everything else, you're looking at untouched Surphaser data. So raw point cloud data converted into polygon data. So again, just incredible detail, very smooth, very clean, very accurate data of this vehicle. So to wrap up this demo of the new Surphaser 100 HSX, again, it's even better data quality, even better accuracy than the current or the past Surphaser, in a new package with battery operation and remote control and smaller size. So this concludes the demo of the new Surphaser 100 HSX.